Lesson 5-6, Graphing Inequalities in Two Variables. An equation defines a boundary. This boundary divides the coordinate into two halves, either a closed half or an open half. So when the boundary is included in the graph, then it is considered to be a closed half plane. When the boundary is not included in the solution, it's considered to be an open half plane. And we're going to look at some example of these throughout the video. So here's the directions on how to graph linear inequalities. So first, you want to graph the boundary. You're going to use a solid line when the inequality contains less than or equal to or greater than or equal to. So anytime you have a less than or equal to or greater than or equal to, you're going to use a solid line. If it does not contain that, so it's just less than or equal to, then it's kind of a dotted line to connect your points. You're then going to use a test point to determine which half plane should be shared. So that means you're picking a point to determine if it's within the plane. And then you're going to shade the plane that contains the solution. So whichever side of the plane that contains the point that works, then you shade in that area. So let's take a look at an example. It says, graph the inequality below. You have 3x minus y is less than 2. So you're first going to solve for y in terms of x, which means you want to get y by itself. So we're going to begin by subtracting 3x from both sides, which leaves you y is less than or equal to negative 3x plus 2. I wrote it this way because you typically want your variables to be first in an expression. So now you have to divide both sides by negative 1. When we divide both sides by negative 1, our inequality flips. So we are left with y is greater than 3x minus 2. So here you can determine that because the inequality only contains a greater than, the line for our graph is going to be a dotted line. So we can graph it because we know that our y-intercept is going to be at negative 2. And then from there we can use our slope to go to count 3 up and 1 over. And we can keep doing that until we get a line. So again, I'm going to use my kind of dotted line because it does not have an equal to. Now from here, you're just going to plug in a point. So let's just choose 0, 0. So if we plug in 0, 0 for our equation, we would have 3 times 0 minus 0 is less than 2. When you're plugging in your points, you always want to revert back to your original equation, not the equation that you got for the line. So this would be that 0 is less than 2. And this is true. 0 is less than 2. So you would then shade in the part of the graph that contains the 0, 0. So we would shade in this half of the plane. So that would be what our graph would look like to demonstrate 3x minus y is less than 2. That means all the numbers to the left of this line would make that statement true. Now let's take a look at an example with a less than or equal to an equality symbol. At this point, you can pause the video and try this one on your own, or if you would like to see another example done for you, you could just continue to follow through. So we first want to, again, solve in terms of y. So we subtract x from both sides. We get 5y is less than or equal to negative x plus 10. and then you divide both sides by 5, but because you're dividing by a positive, it's just going to stay the same. So you're going to have y is less than or equal to negative 1/5 x plus 2. So if we just come over and we kind of sketch out our graph, our y-intercept is positive 2, and then our slope is negative 1/5. So we go down 1 and over 5. And you can do that again. I usually like to get about 3 points just so that I can kind of have a little bit of an idea of where my graph is going. Now, this inequality is including, so we're going to have a solid line for this graph, and mine's not perfect just because I'm sketching. But now you have to determine what side of the graph has to be shaded in and if it includes the point. So I'm just going to select a point, and let's say that we select the point 3, 3. I go back to my original equation and I try to plug in 3 plus 5 times 3 is less than or equal to 10. So this is 3 plus 15, which is 18, is less than or equal to 10, and we know that this is not true, which means you would only shade in the graph that does not include 3, 3. So 3, 3 would be up here. So this would mean that you would want to shade in the bottom half of the graph to show that that half of the plane is included in this inequality. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video. If you need some extra practice or some extra guidance through examples, please refer to your textbook on page 315 and 316.